Light is the fourth dimension of architecture. Light enables us to see and to perceive our environment. But more than this, in its domesticated form as artificial illumination of cities and buildings, light makes a cultural contribution comparable with architecture and the visual arts. As places of encounter and contemplation, museums represent a particularly demanding lighting task. Optimum, unobtrusive light in a museum allows visitors to experience art intensively, revealing the exhibits in full detail. The neutral reproduction of textures and materials makes encountering the masterpieces of art history a powerful and unforgettable experience. At the same time, criteria of efficiency, sustainability and economy must be fulfilled. Thanks to the introduction of the LED into architectural illumination, diverse requirements can now be satisfied to an extent never before possible. High-performance lighting instruments for this transformation of technology into culture are being developed by ERCO, the Light Factory. The guiding principle at ERCO is light, not luminaires. This means that our primary efforts are focused on solving the lighting task in hand, and only then does the design of the luminaire emerge. ERCO has long been known for providing architects and lighting designers with high-quality light tools, and we will continue to follow this maxim in the age of the LED. ERCO recognized the potential of the LED for architectural lighting very early on. We see this potential on the one hand in the LED as a point light source, producing a very brilliant light. And on the other hand, the small dimensions of LED electronics open up completely new design approaches to the luminaires themselves. And the greatest potential is certainly in the field of energy saving, since LED luminaires with appropriate LED lens systems are vastly more efficient than classic analog lamps with reflectors. We adapted to this technology change very early on and started to develop enabling technologies, both in the field of LED lens systems and in operating electronics for LEDs with corresponding software, in order to offer integrated systems, which we've been progressively bringing onto the market since 2008 or so. True to the motto, for ERCO everything changes for the customer as little as possible, one of our benchmarks for this technology change was to make the transition to using digital luminaires as easy as possible for our customers. So we have respected all previous experience, practical requirements and planning practices in developing new LED lighting tools. In recent years, the metaphor of the horseless carriage has figured large in our discussions on product strategy and product design. When a technology is market-ready and leads to marketable products, it usually first turns to established models before eventually finding its own form of expression and characteristic image. Technology change normally needs several product cycles to establish this product structure. The Logotech launch clearly reveals the change product structure and design idiom resulting from the new LED technology. With a conventional Logotech, the structure consists mainly of lamp socket, lamp, reflector and separate control gear. By comparison, the LED Logotech has a very compact housing, which is flat to accommodate electronics that function through good thermal linkage to the housing. It integrates light generation, optical deflection, and control electronics. The LED Logotech has a design idiom and product structure appropriate to the technology. In the design, of course, we're concerned to meet customer expectations in terms of aesthetics and form, and also, very specifically, to make products that function well in an architectural context. As a brand, we're also required to offer clients a corporate design that will last and function for a long time. In this respect, we can compare a component of a product from 1986 with a new product from 2011. Ultimately, Logotech should feel as familiar and uncomplicated as possible, since at the moment of use the technologies employed are not important. First and foremost, we provide light solutions and not LED luminaires. LED luminaires demand integrated technological approaches, and very early on at erco we tackled this technology change by adjusting the skills in our development department. For instance, we established teams for developing LED lens systems and new groups for developing electronic control gear for LEDs, as well as writing the software needed to operate complex LED luminaires. So we're able to offer integrated LED systems which represent the optimum interaction of LED boards, LED optical systems and their control electronics, plus integrated software. The heart of every LED luminaire is the LED circuit board or module. We exclusively develop these LED modules ourselves at erco, in order for each LED module to be optimally attuned to the specific lighting task and the particular luminaire. The essential criterion for the light quality of an LED luminaire is the careful choice of the LED itself. Erco uses only the best LEDs from leading LED makers and specifies these according to very strict criteria regarding color coordinates, color temperature, luminosity, and especially color rendition. This is known as the LED binning. To ensure these quality levels, our development engineers work very closely with the LED manufacturers.
The
LED is fundamentally different from other lamps because it's a semiconductor, an electronic component, as opposed to conventional components which are temperature radiators, and therefore set different challenges. LEDs are very efficient lamps, which makes them attractive for use in architectural illumination, since they optimally project the light forwards, with no loss radiating backwards into the luminaire. Optically, this creates different challenges. Instead of working with reflectors, we can use lenses, PMMA components, which collect the light emitted into the front segment and direct it forwards. Instead of reflector technology, as in the past, the focus is now more on optical elements, using projection rather than reflection. We have developed a digital toolbox consisting of patented spherolit lenses which can achieve light distribution ranging from narrow spot to wide flood, plus oval flood and wall washing, all the characteristics of reflecting systems. This means lighting designers can use either to achieve the same characteristics, identical light distribution, so the systems are interchangeable. This means changes can be made at a later date. If, say, the design called for a low voltage lamp and a reflector for the desired light distribution, then the need for higher energy efficiency brings LED lamps into play. We can now offer lighting technology consisting of LEDs, collimators and spherolit lenses, allowing for a later exchange with the same light distribution. Erco made the conscious decision not to use commercially available modules, but to develop our own systems, starting with circuit boards with our own layouts, fitted with high-quality LEDs, combined with optical systems designed and manufactured in-house and therefore of the required quality. We combine collimators with spherolit lenses, tertiary lenses, to provide precisely the light distribution the designer requires. LED luminaires are of modular construction, comprising 3 lighting technology parts. First, the metal circuit board with the LED. The LED has what's known as a silicon bubble, the primary lens. On this comes the collimator, the secondary lens, by means of which the Lambertian light emitted by the LED is parallelized and focused forwards. Then the tertiary lens, a patented spherolit lens, achieves the final light distribution. The optical systems are developed by virtual prototyping. First, in a radiation simulation, an optical system based on the LED is built up. The LED itself is also modeled here. The radiation pattern shows how the light distribution emerges from the optical system. This is optimized until the results are satisfactory, and then the first prototypes and tools are made. The whole value creation is in-house. We start with the optics development, then take the 3-dimensional CAD data directly to the tool-making department and make the tools. Then we can produce samples in our own plastics molding department and actually see the finished result. Next, the results are tested in a mock-up to see whether the light distribution is as required, and then, if necessary, further optimizations and changes are made. Let's look at that again on this demonstration stand. We can see how the parallel light of the LED is radiated forwards, focused through the collimator. Depending on the tertiary lens we use, the patented spherolit lens, we can achieve light distribution ranging from a narrow spot to a relatively broad distribution, a wide flood. As you can see, it's much broader. As well as rotationally symmetric characteristics, we can also create axis-symmetric or asymmetric light distributions, such as an oval flood. The light here is spread uniaxially, narrow in one axis and wide in the other, resulting in an oval beam. The combination of wall washing and LED technology in particular enables enormous energy savings to be made. On the one hand, the perception-oriented application of wall washing means the illuminance level can be significantly reduced. And on the other hand, LED wall washers achieve especially high efficiency gains. Unlike other lamps, LEDs emit no ultraviolet or infrared radiation into the forward segment, but merely heat to the rear. The heat must be discharged via heat sinks through linkage to the housing, involving mechanisms such as heat radiation, conduction and convection. The crucial point is that only passive cooling is involved. There are no active components with their own life cycles, just passive cooling through the heat being discharged via the housing to the environment. It's especially important that the maximum junction temperatures of the LEDs are not exceeded, to ensure the required performance throughout the entire life of the LED. As with the photometric simulation, we also use virtual simulation methods here, thermal simulation, to achieve optimum heat management of the LED. Using simulation, we can determine the thermal behavior of the LED in the pre-development stage and design the ideal heat sinks for each luminaire. The core competency of optoelectronics at erco covers the fields of optics, electronics and software. These synergies allow certain features to be used very efficiently for the customer's benefit, such as integration in the structure of a flat luminaire like this, or the use of combined potentiometer and phase dimming. So we decided at erco to develop our own control gear in close coordination with our other competencies. At erco we developed some control gears ourselves because, as we see in this Logotech, the construction is decisive. You can see here the integrated potentiometer, which can be controlled externally with no additional circuit board. So we derive great benefits from the construction, which we couldn't find elsewhere on the market. The Dali control gear offers additional features. Alongside normal Dali system dimming, there's also the erco-specific coding, which enables customers to identify erco luminaires easily and directly via plug-and-play in the control system. Looking at LEDs in the context of lighting control, we can see the outstanding advantages of these lamps. The dynamics of the LED mean that dimming can be effected using pulse width modulation with a very high frequency, allowing for optimum exploitation of energy-saving potentials. Energy savings achievable through LEDs themselves are multiplied through control systems, particularly when sensors are used for the lighting control system, especially erco's daylight controls, so that the dimming level of the LEDs can be adapted as desired, according to daylight levels. This ensures uniform general brightness, while nevertheless exploiting energy-saving potentials. LED technology is the high-efficiency alternative for architectural illumination. The erco Light Factory produces lighting instruments which combine the highest quality of illumination with efficiency, sustainability and economy. A transformation of technology into culture. For us, light is the fourth dimension of architecture.